Cambridge Computer Science, Chapter 7, Algorithm Design and Problem Solving, Part 2, Procedures and Functions. Okay, we stopped last session after saying that module or a subprogram or subroutine is part of a program, not a whole. Okay, and then we did module definition and module. So in that part, we were talking collectively about a module. However, a module would be one of two things, a function or a procedure. Okay, let us start first with a procedure because the procedure is easier. And you already know that a procedure does not have to return a function. We have to see that today. And also a function needs to return a value. We have to see that today. So let us start with examples and show about procedures and functions. I have tools here because I have Python that is still running the same program. Okay, I also have a website like this that is allow me to run pseudocode. Pseudocode is not intended to be run. However, it just helps you to understand what is being done. If we can do it with Python, Python is more professional. If we can do it with pseudocode, pseudocode is closer to yourselves. Okay, so let us start with a procedure. A procedure is part of a program that does not have to return a value. However, it is used to perform a function that is frequently used, and it can be called or must be called from the main program. Okay, a procedure is a set of programming statements grouped together under a single name that can be called from other to perform a task at any point of a program. We have seen here calling a module, and that module will become a procedure because it does not return. Okay, a procedure is a subroutine that does not have to return up. You have to remember this and keep saying this all of the time. I keep reminding my students about this. You can run pseudocode in the website, this website or that website. Okay, I can use these websites to run pseudocode. Okay, let us start with procedures without parameters. What is that parameters? The things that may go inside these brackets. We call these parameters. Actually, right now, we are not using parameters. Okay, let us study that procedure without parameters, and then let us explain another procedure that uses parameters, and I hope it will be easy for you to follow. Okay? Okay, so this is the procedure definition. Okay, let us play with it. Let us play with it using Python first. Later on, I will skip Python and focus on pseudo. Okay, so, okay, let us get rid of that code. This is the procedure definition for a procedure called print. Okay, this procedure will do two statements. Print that many stars and then print that many equal signs as if it is underlined. Okay, let us run. As you can see, nothing has happened. Why? Because there is no calling. Okay, let us call it. So if you want to call, then it is running. So this is a procedure definition, and this is procedure derivative. Def is a keyword used by Python for procedure definition. Def comes from definition. So this is the definition itself. And this is the calling. You may call it several times as you wish, as you can see. However, it only needs to be defined once. Okay? So as you can see, these two lines are done because of that first calling, and the next two lines are done because of that second calling. Okay? Okay, procedure without parameter. Here is an example of a procedure without parameters in pseudocode. You need to study very well that code. Very soon, I will get away from Python and I will focus on pseudocode. So, in procedure definition, in pseudocode, you need to write here procedure and the name of the procedure. And brackets here are empty because there are no parameters. Later on, we will put parameters. And the lines will be output whatever, and this is end procedure. Do you think we can try to run this pseudocode? Let us try to run this pseudocode using the website I am showing you. Okay? Actually, pseudocode is not meant to be run. Pseudocode is part of the design stage, is not coding. However, I can show you how it will perform. Okay? So let us copy this and put it in that website, hoping that it will work, because that website, this is IGCSE pseudocode compiler. If you can run this, see, so output hello world, it is working. However, it's not working with all codes I'm writing. Okay, so this is procedure, print stars, it outputs stars and then outputs equals in the form of an underline. Okay, and when it runs, it just does nothing. Why? It hasn't been called. You need to call it. Okay, okay, okay. However, calling a procedure in Python is written like this with the keyword call. This is what you need to study. You need to study pseudocode. You don't need to study Python. Okay, so this is the call. Call to print stars is going into here. So let us run it. Okay, so because of this call, these two lines are printed. Let us call it again. So if you call it twice, and then it is executed twice. However, in pseudocode, to call a procedure, or you need to write the keyword call, C-A-L-L. And this wasn't in PyCharm or Python. So let us focus on pseudocode from now on. Okay, then the procedure can then be called within the main part of the program as many times as required. This is code. So this is pseudocode, this is Python, just for understanding. Okay, and that procedure was without parameters. Okay, without parameters, because brackets here were empty. Let us introduce procedures with parameters. Okay, actually that code looks a little bit complex. I don't want you to study that complex code. I only want you to study things between brackets here. This is what I'm here to explain. First, I will play with it using Python. Just for playing, just for figuring out. So this is the procedure definition. However, to call it, it is expecting a number. And this is what is meant by parameters. It is expecting a value for a variable called number. So number is a parameter now. It will need it somehow. So for example, if you send 10, it will print 10 stars. I will show you right now. If you want to call it, you shall provide a value in the calling. Okay, so if you send 7, 7 will go into here and the loop will repeat 7 times, and this is 7 stars. If here you put 10, you call it again, okay, 10 goes into variable number, and this is the parameter, and the parameter affects how many times the loop will repeat, and then it prints 10 stars. If you make it like 30, okay, you have more. You can call it twice. Once, yeah, for example, once with 10 and once with 30. So see, this is the code with a parameter value 10, and this is the code with parameter value 2. This is just to show you what is meant by parameters. Okay? Okay. Let us study the pseudocode because this is the thing that you are responsible of. I can copy this. Fortunately, I can copy this and put it in that website. Okay? And then when I clear and when I run, nothing happens. Why? Because there is no calling. Okay? Okay? You need to study that structure. The procedure starts with the keyword procedure. And then this is the name of the procedure. And these are the parameters it is expecting. It is expecting one parameter called number, and it is of data type integer. It is expecting a whole number. And then declare counter, there is another variable here, and it is declared here. All these things are totally new for you. Just let's play with it. Let us just play with it. Here is a code with parameter 7. And run, you get 7 stars. Okay. Another call with, for example, 10. You clear and run, and this is even more stars. So this 10 goes into here. This is what is called by parameter. And that 10, I call it an argument. Arguments and parameters are just the same. Okay. Procedure with parameter call is like this. To print 7 stars, you print 7 here. The procedure call must match the procedure definition. This is the procedure call, and this is the procedure definition, and they must match. Okay? This means that when a procedure is defined with parameters, arguments, this is called arguments, this is called parameters, and they just match. Okay? Arguments in the procedure call should match parameters in the procedure. Here you are sending an integer, here you are expecting an integer. Okay, so that was about procedures that do not return a value. And one of them, in an example of a parameter without an example of a procedure without parameter, an example of a procedure with parameter. Okay, let us now go and have some examples about functions. Functions are exactly the same like procedures, but they do return a value. I will show you what is that return a value. Okay, a function is a set of programming statements grouped together under a single name. It is exactly the same definition as a procedure that can be called to perform a task at any point in a program. Exactly the same. In contrast to a procedure, a function will return a value back to the main program. I will show you that value returned very soon. Okay, unlike procedures, another dissimilarity, functions calls are not stand-alone. Instead, can be made on the right hand side of an expression. What does this mean? I will show. I cannot describe it. I only need to show it running, inshallah. The keyword return is used as one of the statements in the function. In the function, there must be a return. Okay, to specify the value to be returned. This is usually the last statement in the function definition. Let us first play with it using Python and then play with it using pseudocode. And later on, I will stop using Python. I will only use pseudocode. Let us go to PyCharm, get rid of all this. This is a function. Why this is a function? Because there is a keyword return. this function will return a value. I will show you right now how it will work. However, to call it, let us put all this code together and then you have a function called convert to cm. It is very simple because it will accept the distance in inches, multiplies it by 2.4, and returns the equivalent distance in centimeters. Okay, so the function definition is called, the function name is called convert to cm, and is expecting an argument, expecting a parameter. Okay, and when it receives, actually when you call it, you have to provide some value in here. Okay, and this value will come in here, inches multiplied to become centimeter, and return centimeter. However, the value returned must be stored in a variable. This is what is meant by must be on the right hand side of an expression. The return is on the right side of an expression. And the result will be stored in my distance. Then when I print my distance, okay, let us play with it. So I am calling it with 10.10. Okay, so the program starts with convert to cm 10.5. Convert to cm, we'll call this 10.05 will be stored in the parameter inches. Inches will be multiplied by 2.4 and stored in variable cm and return. This is a function that returns a value. So this is the return. So it returns a value. That value comes into here. And it is on the right hand side of an expression that will be assigned to the variable my distance, and then print my distance 25.2 will show on this. If you run it again here with 20, the same story, but for example, that why there have so many fractions? Because this variable is of data type real. Okay, it has fractions. Okay, let us study the same thing using pseudocode. Why? Because this is the way you should study. A function should start with the keyword function. It should start with the keyword function. Okay, let us put this. The code looks a little bit complicated. The most important thing you need to study now is the keyword function and end function. And you have here a parameter. And that function returns real. After calculating, it returns a real value. Okay, if you run it now, nothing will happen. Why? Because there is no code. Okay, let us copy the code. And as you can see, the code, there is no keyword code. It's on the right hand side of an expression. So convert to cm, we'll call this, and that 10, let us run. So see, it is behaving. However, here in pseudocode, the assignment is an arrow. Okay, and this is the call for that function. 10.5 is argument that goes here as a parameter. And then that function will return something real, because here it says return cm, and cm is a real variable that stores fractions. That value will be returned here, assigned to the left part of the expression, and then print my distance to show it on the screen. If we want to run it again with another value, so we're getting the same result. This is pseudocode. You need to study those commands and be familiar with them. Okay? Okay. Let us look at another function and another function, or maybe stop somehow very soon. This is another function copied from the past paper because that was on the March 2023. Variables x, y, and z. Now we are introducing you to variables. Variables x, y, and z are used in programming. X stores a whole number. There is something called declaration. Declare x as integer because x stores a whole number. So I do declaration, declare x as integer. Declaration is the process of assigning a data type to a variable. Y stores a decimal, so declare y as real. Z stores a flag that would be true or false. Yes, excellent, Boolean. So declare Z Boolean. The function same, I'm getting complicated. The function same returns true if the value of A is the same as a value of B after B is rounded to the nearest whole number and false otherwise. Let's try to play with it using pseudocode directly. So we have a function called same. It takes A as an integer and B as real. Okay. So variable B will be rounded into 0 decimal place and compared with A. If they are the same, it returns true. If they aren't the same, it returns false. Let us see how we can play with it. So now we have x has the value 10 because x is integer. Y has the value 10.1. Y is real. And the same is called to this. With x and y, the 10 and 10.1. And the result will be stored in Z and output Z. Let us try to run it. The output is true. Why? Because Y 10.1 is accepted here as B. 10.1 rounded to 0 decimal place, it becomes 10. And then A is also 10. So this comparison, that if then else, returns true. Okay? Actually, I would like you now to see that this is a function with arguments or parameters. And as it is a function, it returns a value. And that value returned must be stored somewhere before being out. Okay? Okay, I will stop very soon. I will stop very soon. I will stop before explaining the library routine. Actually, the function round is a library routine. It is pre-written and I'm just calling it. Okay, but I will keep this for the next session, inshallah. So function definition and function call. This is the function definition and this is the function call. Okay, let us keep now. From now on, I will focus more on pseudocode. Function definition is setting up the function. This is the function definition. And the function is defined only once. You need to define only once. Function call is using the function. This is function call. And the function may be called many times. Okay, what are parameters? These are parameters. These are parameters. Because we are having here a function with parameters. These are parameters. Parameters are the variables that store the value of the arguments. These are arguments. So the 10 and 10.1 will be here in X and Y. X and Y are arguments that go here into parameters. They are just the same. Okay. Passed to the procedure or function. Some but not all procedures and function will have parameters. Scope of a variable, local variable. This is a local variable. This is a local variable because it is declared inside the program. This is a global variable because it is declared outside the subprogram. When it is declared inside the subprogram, it is local to that subprogram. When it is declared in the main program, it is global to all. The scope, we call this the scope. A local variable, it can only be used by that part of the program it has been declared in. Its scope is restricted to that part of the program. Example, the scope of the variable declared in the procedure is local to that procedure. Global variable, a global variable can be used in any part of the program. Its scope covers the whole of the program because it is declared in the main program. The only thing we only need to study now, library routine, a standard subroutine that is available for immediate use. The example I have here is the library routine round. It is available for immediate use. Its programming is very difficult. I don't need to program it because it is already programmed in the library of the programming language. Structure diagram, an overview of a program or subroutine. Procedure, a subroutine that does not have to return. Now you have seen yourself how a procedure does not return a value and how a function should return a value. Function, a subroutine that should always return a value. I will stop here and later on, inshallah, we do library routine. Thank you very much for your attention.